For decades, we have been operating under the Standard Model of Cosmology. It has been a triumph of human intellect, a framework that explains the history, structure, and composition of our universe, from the Big Bang to the present day. We thought we had the recipe for the universe down to a science, but, as it turns out, our recipe might have been missing a few critical ingredients. When the James Webb Space Telescope, JWST, began sending back its first deep-field images, it wasn't just capturing light. It was capturing a challenge to our most fundamental understanding of how the universe evolved. We built the James Webb to look further back in time than any instrument before it. Its infrared capabilities allow it to penetrate the dense primordial clouds of gas and dust that have obscured the very first stars and galaxies from our view. The expectation was that we would see the building blocks of the universe, small, nascent, and chaotic structures just beginning to coalesce in the cosmic dawn. We expected to see the universe in its infancy, characterized by a slow and steady assembly of matter. Instead, Webb revealed something entirely unexpected. It showed us massive, mature, and complex galaxies, existing just a few 100 million years after the Big Bang. According to our established models of galaxy formation, these structures should not have had enough time to form. The timeline was compressed. Galaxies that should have taken billions of years to evolve to this level of complexity were suddenly staring back at us from an epoch where they simply shouldn't exist. It is akin to planting a seed in the morning and expecting a fully mature, ancient oak tree to stand in your backyard by lunchtime. This discrepancy highlights a potential flaw in our understanding of early star formation. If galaxies could reach such maturity so quickly, our models for how gas collapses to form stars and how stars coalesce to form galaxies may be drastically underestimating the efficiency of the early universe. The mystery is not that the universe is broken, but that our understanding of the speed of cosmic evolution is incomplete. This is further complicated by the discovery of supermassive black holes at similar, impossible-to-reach early epochs. Black holes grow by accreting surrounding matter, stars, gas, and dust. For a supermassive black hole to reach the sizes we are observing, it would have needed to feast at an incredible, nearly impossible rate for its entire existence. The current models of black hole growth, governed by the Eddington limit, a cap on how fast matter can be pulled into a black hole before its radiation pressure pushes the matter back out, simply do not allow for the growth we are seeing. Either our understanding of these limits is wrong, or there are mechanisms for black hole formation and growth in the early universe that we have yet to discover. Then, there is the Hubble Tension. For years, astronomers have been measuring the expansion rate of the universe, the Hubble constant, using different methods. One method relies on the cosmic microwave background data from the early universe, while another uses local observations of supernovae. The problem is that these two methods, both of which should be accurate, yield different results. This discrepancy is not a minor error. It is a significant statistical tension that suggests our cosmic recipe is miscalculated. These revelations are not a sign that we should abandon our theories. Science is a process of refinement, not revelation. Every anomaly is a new data point that forces us to sharpen our tools and rethink our assumptions. Whether the solution lies in new physics, a more complex understanding of dark matter, or a fundamental revision of our timeline, Webb is forcing us to confront the limits of our knowledge. We are looking into the deep history of our universe, and for the first time, the universe is looking back with a complexity we weren't prepared for. We are not just observing the history of the universe, we are actively rewriting it. We're rewriting the history of the universe in real time, but there's so much more darkness left to explore. If you're ready to help us decode the next cosmic secret, subscribe to Cipher Quest and stay with us on the journey.